Okay, what you're looking at here is a table of all the common symbols that are used in a pedigree chart. So I just want to go through these with you before we start talking about pedigree charts, just so you know. Okay, so males are always drawn with a square, females are always drawn with a circle. The line between the male and female just means they have children together. So it's a mating line. And then the line down from that indicates their children. So in this, and they're always put in order of birth. So here we have two parents who had a boy and then they had a girl. Twins here, so these would be dizygotic twins. So these are non-identical fraternal twins. So you would have them on the same line like this, and because you're just indicating that they were born together. So dizygotic can be a boy and a girl like this one here, or it could be two boys or two girls. And then this one is monozygotic, where you would never have a boy and a girl like this symbol is showing. You would have either two girls or two boys, and you have a line between them just to indicate that they have the same genotype. So this one here is sex unspecified, meaning that maybe you've gone back numerous generations and you just don't have the information about whether the children were male or female. And then sometimes you can just do it like this if it doesn't really matter to you the problem that you're solving. Like there was 4 male children in the family and 3 female children in the family. If you're not writing in the genotypes, like we're going to be in the when we do the problem on the whiteboard, you can shade in half the circle or the square halfway, and that will indicate that they're heterozygotes for the autosomal recessive condition. This one, don't really use this one too much, at least I never do, but this is how you would indicate a carrier of a sex-linked condition here. This means the person is deceased. Like, so if you're doing a one on a current family, you can just draw a line if the person's not alive. This little symbol means sex unspecified. It means maybe that there was stillborn children in the family, so you could just indicate it like that. Proban is a term that just means the person that the pedigree is chart is being done for, like the person of interest, and we're probably not going to end up using that too much. This little chart here, I'll go through this again in my presentation on the whiteboard, but this is just a way of indicating or identifying persons in a pedigree. So you always numerate your generations with Roman numerals, and then just regular numbers for the people in that generation. So for example, I could talk about person 1, 2, and I would be referring to this person. You'll also notice that this person is fully affected, and I should have talked about that here, not as opposed to here being halfway affected, being a heterozygote. That means this person is fully affected. So if you're not writing in the genotype, this is how you would identify that that person has the 2 recessive alleles. And this is just showing you here that this person is affected, and it's person 2 in generation 2, second person in. This one here is consanguineous marriage. You can't quite see that, and I don't know how to do this, but anyways, that's just showing like 2 people with a mating line, but they have an extra line. Oh, there it is. So that indicates that they're closely related people, possibly cousins or something like that. So that happens. And then here's an example of an actual pedigree. This would be for a recessive condition where we don't have any information written in. So we can see that this person, these two people were married. They're both heterozygote. So both of them are healthy, but they're carrying a recessive allele. This line is for their children. Now the lines down from it indicate their children. So they had a girl and they had a boy and they had another girl and they had a boy. So they had 4 children. Now these children had spouses. So this girl married a man who was a heterozygote. And this boy of theirs married a normal female. And just move my face. And this affected male married an unaffected female. And then you can see that they had children, and it can go on and on and on like that. So what I think is most helpful is to actually work through a family tree with a recessive autosomal condition and see how that actually works. So I'm gonna go to my whiteboard, and I have sent you a story. And if you pause here and read it, if you've not already done so, it's going to make a lot more sense. So do that, and we'll go do it on the whiteboard. Okay, we're going to be looking at a pedigree chart. And this pedigree chart is for a recessive condition. And I've sent everybody the handout that goes with this. There's a little story that you can follow along. I would suggest that you try working through this pedigree chart. You can stop and start the video as you need to. So the pedigree chart, the pedigree story starts us off with talking about a man who has a recessive genetic condition, and his name is Anthony. So I'm going to put him here on the chart. Just write his name here. Okay. And then it talks about how he marries this or meets this woman, and her name is Betty. And so I've put her on the chart there as a circle because females are always designated with a circle and males are always designated with a square. And the line between them indicates mating, indicates that they have children together. And so to put in their children, we just put a line down, and then we can put their children on this line here, showing that they're in the next generation. So they had, first of all, it says 2 boys. So that's 2 squares. Their names are Sam and Jamie. And then it says they had a daughter, and her name is Ellen. Then the story talks about, hopefully you've already kind of read it because I'm just going through it quickly. It talks about their neighbor, Patty, and how the dishwasher repairman and her got married and had children. So I'm going to put them on the same line because they're in the same generation as Anthony and Betty. Now these people are not related to one another right now, but they're going to be in the same pedigree chart because their children are going to be married and have children together. But as it stands right now, these people are not related in any way to one another. Anyways, I will write her on this circle and Morgan here on this circle. And then it talks about how they had children, and they had 2 boys.
Okay, so far, so good. We've kind of got almost 2 different families, but then these 2 get married. So we've got a mating line between those 2. And then it talks about how they had a son. So now we've got 3 generations of people here. So in most pedigree charts, that's going to be indicated, the generations, with Roman numerals. So that would be 1st generation, 2nd generation, and 3rd generation. And then what you'll see on most pedigree charts is these are numbered. These people are numbered on each line. So the most common way to do it, I think, is 1 to 4 here and then start again. 1, 2, 3, 4, 5, and 1. But I have seen pedigree charts where they go 4, 5, 6, 7, and it probably really doesn't matter. Just as long as you understand that this is just a way of keeping track of people in a pedigree. So for example, you might talk about person 2, 3 instead of talking about Ellen. Or if I said person 1, 2, I would mean Betty. Or if I said person 2, 5, I would mean Mo. Okay, so that's just how it's commonly done. So this next part wants us to draw out the pedigree chart, which we did. Include everyone's genotype. Okay, so genotype. So we have got the information that we're using a small h for the recessive condition of having a horn and a big H for not having a horn. So we know it's a recessive condition, so if you have it, like this guy has it, person 1, 1, he'll have 2 small h's. Now who else has it? Ellen has it, so we'll give her 2 small h's. That's her genotype. We're also told that person 1, 4 has the condition, so let's do that. And this person 3, 1 has the condition. Okay, so that part's easy enough because we're given that information in the story. Now we just have to figure out the rest, as many as we can. So Ellen got 2 h's, so she had to get 1 from each parent, and you can see that she got 1 from Anthony quite easily. I'm going to use a different color here. So yeah, so one of these is from Anthony. See that? But the other one had to be from her mom. So her mom gave her 1, but her mom doesn't have the condition. So we know that she also has an unaffected allele. So she's heterozygous for her condition. Okay, so that makes sense. So 1 H came from her mom and 1 H came from her dad, one affected allele. Now these 2 brothers, they don't have a horn. So they obviously both got the H, big H from mom. And the only thing they could have got from Anthony was the little h's. Okay, so that solves that part. Now, Eric here, he's got, from his mom, he got a little h, and he had to get 1 from Joe as well. Okay, but Joe does not have a horn, so we know he has a big H. Also, person 2, 5 does not have a horn, so we know he has a big H. The only allele that his dad has is little h's, so he had to get a little h from his dad. Now, these guys, we went ahead and gave them both a big H because they didn't have a horn, and we know that Patty doesn't have a horn, so it all makes sense because they obviously got the big H from their mom. What we don't know for sure is what her genotype is. There really is no way to tell because this will work out whether she's homozygous, dominant, whether she has two big H's or whether she's heterozygous and this is another little H, it'll work out the same either way. So the question does ask us, says, are there any individuals that you are not sure of the genotype? Well, Patty, other than knowing that she has one healthy allele, we don't know what the other one is for sure. Okay, so question 2 says, if Ellen and Joe had more children, what is the likelihood of their children having a horn? Use a Punnett square to support your answer. So I suggest you give that a try, pause the video, and then come back and we'll do it together. Okay, so I'm going to do this Punnett square here for Ellen and Joe. If they had more children, what is the chance that their child would not have a horn or would have a horn? They already have a child with a horn. Okay, so Joe, there's his genotype, and Ellen, there's her genotype. And we'll just work through this. And you should be able to see that there's a 50-50 chance. So 2 out of 4 chances that there's a horn, and 2 out of 4 chances that their child is heterozygous and does not have a horn. Okay, and that is solving a fairly simple recessive condition pedigree chart. So we will be looking at a couple more, as well as trying sex-linked condition, and just so I can show you the difference between a recessive condition and how you go about doing a sex-linked condition pedigree chart. And that's it for today.